Here we're given the system 5x minus 6y equals 23 and x equals 6 minus 3y. It's precisely the same system we were given in the previous video, but the instructions are different. Here we're told to solve this system using a different method. We're using the elimination method. This coincides with note number 116. Okay, so before we start, first we want to get all equations into the form y equals, it's not y equals, but capital A times x plus capital B times y equals C form. Okay, so let's do that to all of the equations. That's the first thing we want to do. Equation A, it is already in the form 5 times x minus 6 times y equals 23. Equation B takes a little work to get it into that form. Let's see, the x is okay, and then add the 3y equals the number 6. So there's our system where we have the x's lined up, we've got the y's lined up, and we've got the equal signs lined up, and we have the numbers lined up. Okay, now we can go to step 1 in note number 116. I'm sorry, it's 116. Note 116, addition elimination method. Step 1, choose the variable to eliminate. So I have to commit to eliminating one of the variables, and I'm going to choose eliminate y. Doesn't matter which one you choose, just stick to it once you choose it. Step 2, I'm going to add an appropriate multiple of equation A to an appropriate multiple of equation B in order to eliminate the variable y that we chose in step 1. And just by examining what it's going to take to get rid of the y, I can see that if I take equation A, which contains negative 6y, and I add 2 times equation B, well, equation B contains 3y. If I multiply it by 2, it'll be positive 6y. So I'm going to be adding a negative 6y to a positive 6y. That's going to eliminate the y's. That's going to give me what I want. So let's do it right here. Equation A, 5x minus 6y equals 23, added to, parenthesis, the result of multiplying every term on both sides of the equal sign of equation B by 2. That gives me 2x plus 6y equals 12. Now, watch what happens when I add it. The y's are going to disappear. 5x plus 2x gives me 7x. The y's cancel each other. Equals 23 plus 12 is 35. So we effectively did what we had intended to. We eliminated the y by adding an appropriate multiple of the first equation to an appropriate multiple of the second. Step 3, well, now I'm happy again. Let me put my happy face, because I only have one variable, which means I can solve for that one variable. Let's do it. Step 3 says solve for the only remaining variable, which is x. So I'm going to divide both sides by 7, the coefficient. These 7's cancel. I get x equals 35 divided by 7 is 5. So now I have my x partner. Let's go on to step 4. Step 4 says substitute this result into either of the two equations to find its partner. So I can choose which equation I want to substitute it in. I think I'm going to go back to the original B equation. No, not the B. Yeah, the B equation is good. It was x, which is now 5, equals 6 minus 3y. Now I'm going to solve this equation for y. Let's continue up here. Let's see, I'll subtract 6 from both sides. That will give me negative 1 equals negative 3y. Then I'll divide both sides by negative 3 to get the y by itself, because these cancel. That gives me y equals positive 1 over 3. And then the last step, step 5, I conclude by writing my solution of the system is the ordered pair xy equals 5 1/3. So we got the same exact answer that we got in the previous video. We used a completely different method. Now I would like you to do a you-try problem. I'll write it here at the bottom. You try I want you to solve by any method. When I say any, I mean any of the two methods that we just saw, substitution or elimination. The following system: x over 4 plus y over 3 equals 0. And that's equation A. The second equation is x over 8 minus y over 6 equals 2. That's our equation B. Okay, so you're going to take that system. It's all ready. Let me put a little cloud around this. I want you to take some paper in your notebook and solve it by any system you choose. And I would highly recommend that you start by eliminating the fractions in each one of those equations by multiplying both sides by the least common denominator for that equation. Then go ahead and choose your method. Now when you're finished, I'll tell you what your solution will be so you can check your answer. The solution will be the ordered pair 8, negative 6. And by the way, because you got a single or a finite quantity of solutions, there's a name for this type of system. When you get a finite quantity of solutions, essentially that means you can count the number of solutions that you have. That system is called independent. We got a finite quantity of solutions for the first one, so we should have identified that as an independent system. And it turns out, because it has one solution, and that's a finite quantity of solutions, it turns out that that's also true about the U-try problem. You get one solution, so it's an independent system.